again, also here, when we are saying the sample frame, we are trying to look for the existing data set. Let's say, for example, I have my data. This is my data set. Maybe let's assume that it consists of 10,000 observations. And then from that, if I use sample underscore fractions, I'm trying to look for the 10% of the data set. So here we are going to select the 10% of my data, just randomly. That's what we normally use when we are trying to select the proportions of the data set based on what I have. So what we do is we write sample underscore fractions, and when we put the name of the data set, comma, put the percentage we are looking for, and we say replace equal to false, which means that keep the data I select at the first time. Once I will run the code again, I will see the data I was having it as I was having it before. So if you say replace is equal to true, it means that at the time I'm running this code, there is also the possibility of getting the different observations, but also in a range of 10%. But if say we replace equal to false, it means that what I get at the first time continue to give that kind of values, that kind of values once I can also run it again. So again, we have sample fractions. Here we are trying to select the 50%. This is also extract random 50% of all rows. Like if we say refresh, there is a possibility of um, getting the difference participant that is coming in my data once I run the code more than once. Okay. So, but also we continue to bring 50% of observations. And another thing, it is top n. We are extracting the given numbers of top rows after ordering by certain variables. Let's say, for example, I want you, if we say top underscore n, what means? I want you to go in my data set called my data and look for top five separate, select the observations, but also basing on top five separate, because I'm interested to look for the highest five observations based on sepal.rem. If you see on the sepal.rem, this is the sepal.rem, you will see that we have the highest five observations. Sepal.rem, this is 7.7, 7.7. It is ordering from the highest. That's why we see this, but it's going to select it randomly, but making sure that it is the highest among the highest they can have. So that's what it means. And those things like select n, select those things like the sample, not select, sample fraction, sample n, and top n. It is also another kind of things we can use when we are filtering observations or when we are filtering rows. And here also it's a way you can use the pipe when you are trying to filter. Let's say I'm looking for my data and go and group it by the species and help me to select the top one observations in separate. That's what we are trying to do. So it is going to look for the species, and also we are grouping the column species and select the top five of each group. Those are what we are doing. But this is not top five, it is also top one. So if I put the top one, this is also for each species, it is going to bring the highest among the highest. That's what it means. And another thing also we have here, we have what we call select, where we are selecting the observations, we are selecting the variables, not observations. If we use select functions, we are selecting the specific variables that we are looking for. Let's say, for example, as I said, I have 10 variables in my data set, but I need to use 5 variables only, so I have to select the variables. You can use also the pipe where you type the name of the data set and then you add the pipe. And the pipe also, it is the shortcut of writing pipe in R programming. We can use Control Shift Enter, Control Shift M, Control Shift M. It is a shortcut of selecting, of writing the pipe. So, and then you put the select, you have to say 1 up to 3, which means you're going to select the variables from 1 up to 3. This is the sequence way of selecting the variables, but also you can write the indexing of the position of the variables that you are looking for, where you can say 1 and 3. Not only this, but also you can select the variables where you can have a possibility of typing the variables that you're looking for instead of using the indexing, but make sure that it is written the way it is. What you have is to write to type the name of the data set, and then you put the pipe, and then you select those kind of things. Not only that, but also you can use the sequence selections where you indicate the name of the data set, and you have to type the name of the data set, you add the pipe, you put the select, and then you specify the variable that you are looking for. And this thing, it is where we are removing the duplicate. Let's say, for example, if we say the duplicate, it is where you are supposed to submit one times, or to answer the question one time, and then by default, or maybe by error, you made an error, you submitted the response, or you respond more than once, while you was expecting to respond one time. That's what we call duplicate. And then for us, those duplicate is going to affect our decision while we are doing analysis, because we are submitting responses more than once, and we have to remove that duplicate. And most of the time, the way we treat the duplicate, we are handling the duplicate, but also focusing on the unique identifier. So if we say unique identifier, it's like an ID. Those are the numbers that is representing the number of the respondent. Each respondent, they has each unique identifier. So we need to look for those kind of things when we are dealing with those kind of things. And again, what we do the distinct, we put the name of the data set, comma, we specify the variables that we are going to focus on while we are trying to remove the duplicate as the unique identifier. So the variable we put here, it's what we consider as the unique identifier. So because of the sake of doing running, for the sake of making it for the running purpose, we put separate, but the separate doesn't mean that is a unique identifier for this data set that we are having here. And then if we say keep all, we are trying to say that do it as much as you can, but also keep the unique identifier after removing the duplicate. So again, also you can specify the variables, more than one variables where you want to take the duplicate. If you see that the separate and petrolem it is similar, try to remove it. Otherwise, if not, keep it the way it is. And we are arranging the variables like order by ascending or descending. You are trying to arrange the observation by ascending or descending. What we do arrange, and then we put the name of the data set, and then we specify the variables we want to make the arrangement of the data set based on. So by default, if we use arrange, it is going to arrange it as ascending, so from the lowest to the highest. So if you want to have it as descending, so what you will do from the highest to the lowest as descending, what you will do, it's like making arrange my data, comma, descend, separate. Those are the kind of things we need to look for once we are trying to look for the descending. So again, this is also the rename. So where you can do the rename, we are renaming the variables. Maybe the way it is not the way we want. So we can rename it by using the rename function, where we type if we are doing a rename, so what we do, we are typing rename, and then we put the data set where the variable are located, and then we put the comma, we put the new name you want to have it as a based on it, we put the new name we want to name our variable, and we put equal by the existing variables. So those are the examples where we have the sepal underscore rem, while in our original data set we was having sepal.rem, but we need to say that instead of having sepal.rem, we no longer need it, let's have sepal underscore rem. And again, here was having sepal.width, but we want to have it as sepal underscore width. So you can also add more than Those are also, I do the rename of the variables, two variables at the same time. You can also do it more, maybe 100 variables. The number of variables you want to rename, you can also do it once. So I think you understand how it works. And then mutate, we are trying to compute the new variables based on existing and keep existing one. So we are generating the new variable based on existing and also keeping that existing. So where we say we use mutate and we put the name of the dataset, we put the name of the variables that we are going to create and put expressions like the calculations or the um, formulas that we are going to use or the conditions that we are going to use once we are trying to generate that new variables. So what we do, we type mutate, we put the name of the dataset, the new name that we are going to create, the name of the variable we want to name it, and then we equal, put the expressions. Here we say that we are trying to create the sepal or sepal peto ratio, where it is going to be equal by sepal length divided by sepal width. So those are expressions that we are talking. And another thing here is you can also you do transmutate. It's like computing the new variables, but drop the existing variables. I'm trying to generate the new variables, but once I generate the new variables, I want you to drop the existing one. So that's what transmitted. And most of the time, it is not advisable to use transmitted because it can also affect you to lose the data set. So we use transmitted when we are generating the final report that we are looking for or we are trying to send to someone. So what we do it is the same. We type transmitted as usual, and then we put the name of the data set, we put the comma, say sample underscore, this is the new name that we want, and then we do those kind of things. And but also we here we do more than kind of things. So if we print the result, we are going to have only two variables. Other than that, it is going to be removed and summarized as a final data manipulations function. It is summarized. We are calculating summary statistics. So we are summarizing summary statistics where either for ungrouped variable and grouped variable. And this is also the way summarize works. So you type the summarize, you put the name of the data set and come. If you say count n something, we are counting the number of observations. Here also I generate the mean of sample range for you. You can also do it as the way you want. As long as you type the variable the way it is, you can also do what you have to make sure that if you are looking for the mean, especially something like that, if you are calculating the mean, we have to add na.remove equal true, because when you don't add na.remove, when we have the missing value in the data set and you are trying to calculate the summary statistic and you forget to omit the missing value, the error is going to give you zero, because those missing value, if they count the missing value, we are going to get the zero. So that's why we normally need to omit those values when we are doing mean, mode, standard deviation, everything that we are doing, especially for calculating the summary statistic, we need to omit the missing value. Otherwise, we have to remove those missing value either by replacing with the mean, either by replacing with mode, either by replacing with median. So there is a lot of possibilities that we can use while we are removing those kind of things. So, and the way we remove the missing value, I think we have seen it when we are dealing with the data frame. So, again, also you can create the group data by using group deploy functions, where we can use also the pipe. Like as I have my data, then I put the pipe. I say group deploy because I want to provide the summary statistics based on the categorical variables. That's why we use group deploy. We are grouping the categorical variables called species, and then we are trying to look for my data where I'm going to look for the species. For each species, I want you to count how many species that is Setosa, that is Virginica. Those are the kind of things. Because of our species, it has only three categories. It is also sometimes, let's say, for example, we are looking for an education level, and then we need to see how many people that is in each categories, for example. That's why we do summarize, and then we count. And not only this, but also you can calculate the mean of sample range, where you put the comma, you put the name you want to give the output, then equal mean, you put the variable, the original variable, comma. Here also I create the mean of petal range, petal width, where it is equal to mean and petal width, but also you have to add comma and add na dot remove equal to true. So the reason why we get the result here, it is because in our data set there is no missing value. But for the case where we have the missing value, we have to add a comma and then we add na dot remove equal to true. So those are also the examples here. I think here we did it where we can add the na dot remove equal to true for us to avoid the issues of getting null values while we are trying to calculate the mean, and yet we know that our variables has a certain observation. So as a conclusion, the data manipulation in ARA also refer to the process of screening, organizing, and transforming the data to make it suitable for analysis. And it is including the task of handling the missing value, summarizing the data, and also we are doing the data manipulation commonly for performed using baseline functions backed by the tidyverse. So we have to note that the tidyverse is important for us to perform the uh, verbs of data manipulation. So as a conclusion to this introduction to data manipulations, I would like to emphasize on the practical side. So I want you to follow the next video that is going to help you to understand the practical code. So this is going to guide you while you are trying to deal with also the practice of data manipulation. So I think you are going to enjoy the session. Let's hope that it's going to be fine and keep pushing, keep doing practice. There is no way of knowing those kind of things. Otherwise, to do the practice, it is a key. So thank you once again for making this course today happen. And I wish you to continue to enjoy the rest of the session.